Now we are going to start evaluating functions when we're giving a formula for that function. So here, f of x is equal to x squared plus 3x minus 4. And we want to evaluate f at 2, then at a, and then at a plus h. So notice there's something interesting going on. We can evaluate f at an expression that's not an actual number. That replaces a number, but that's not an actual fixed number. So a is something that could be an arbitrary number. So maybe to understand what's going on, I like to view functions in two different ways that may help you to understand how we're going to evaluate that function. So you can think of, x here, this is your input, right? Yx, well, because x here is a variable, and we usually use x for the symbol of a variable, but that's because crosses are easy to make, right? So this is a convenient letter to use, and that's a possible way of illustrating what the input is. But sometimes I like to put, instead of an x, a little box, okay? And I tell my students, you can put anything you want in the box because that's going to be your input. And the output is going to be what was in the box that you're going to square. And you're going to add 3 times what was in the box. And then at the end, you're going to subtract 4. So just to give you an idea that looks maybe stupid, you can put 2 in the box. And the output is going to be 2 that you squared. Then you add 3 times 2 and you subtract 4. So that would give you, for a, f of 2 is 2 squared plus 3 times 2 minus 4. So that gives you what? 4 plus 6 minus 4. You get 6. So this is our answer when the input is 2. And we could do something similar if we had another number for the input, right? Just replace x by that number. Now let's take a look at b. Okay, so let's see what the input is. The input is a. So I can put anything I want in that box. So if I put a, what comes out of it is a squared plus 3a minus 4. As simple as that. So it's as if really we've replaced what stands for the input for, which is x initially, for some other letter, which is a. So of course we're going to get 3a squared plus 3a minus 4. Now, why would we do that? It's because, especially in calculus, often we have x. We use x as a symbol for a variable, and we use a for a fixed number. Okay, so x is really something that usually can vary, but in a problem, a is actually something that was fixed initially in the problem. Okay. So maybe it's going to be a bit clearer not in the next example, but in the one that comes after it. So let's say now I want to evaluate f of, actually I don't want to evaluate f of a plus h, I want to evaluate f of 2 plus h. So what's f of 2 plus h? Okay, so once again, let's go back to our little box. So what I'm going to put in the box is the input. The input is 2 plus h. It's 2 plus h is a single quantity. So the output is going to be that quantity, that input, squared. So I'm going to put it in brackets because all of 2 plus h is going to get squared. And then 2 plus h, all of that will get multiplied by 3, and we're going to subtract 4. So let's write it down here. So it's going to be 2 plus h squared plus 3 2 plus h minus 4. So that's really our output. If we want to, we could expand this and group like terms. Okay, so I'm going to do that. So the first term is it's the square of a binomial. So I'm using a plus b squared is a squared plus 2ab plus b squared. So 2 squared is 4 plus 2 times h, 4h plus h squared. And then 3 times 2 is 6, 3 times h, 3h minus 4, and finally I can simplify this a little bit, and I'm going to reorder it so that I go from increase the largest power of h to to basically the constant term in the end. H squared, 4h plus 3h, 7h, 4 minus 4 plus 6 is 6. So that would be my simplified output. So of course it's in terms of h. I don't know what h is. So if the input contains h or something that's here h could be a variable, it could be something that's fixed, but we don't know what it is. That's the thing. So so the output is going to depend on that. Okay. D, here's what we're going to do. We're going to evaluate f of 2 plus h minus f of 2 over h. And we're going to simplify, evaluate and simplify. Now, why would we want to do that? Okay, imagine this is the graph of f. So in fact, if I look at f, it's going to be a parabola. Maybe I could do a better job. I know exactly what this parabola is going to look like. So let's take just a second to figure out what the graph of f is going to look like. So it's x squared plus 3x minus 4. So to graph a parabola, you've learned if you can factor it, you'll be able to graph it immediately. So by factoring it, we can find the x-intercepts. So there's 4, or minus 4 is a 0 is an x-intercept. 1, 0 is another x-intercept. We're going to find in between the vertex, so I'm not going to worry too much about where the vertex is. There's what's the y-intercept? The y-intercept is when you replace x by 0. Right, so we're essentially graphing this, right? So if you replace x by 0, all this becomes 0, and you're just left with minus 4. So minus 4, 0 minus 4 is the y-intercept. And the vertex would be in between the roots, or the x-intercept. So it's going to go a bit, you know, this is a parabola that's going to go down like that, and then eventually reach the vertex somewhere here. Okay, which we calculated. The x-coordinate would be the average of 1 and minus 4. Okay. Now, what we're interested in calculating is, well, we calculated f of 2. Let's say 2 is here. So this is f of 2. And this would be 2 down here. Now, imagine that we increase 2 by a small quantity. Let's call that quantity h. So we increase 2 by I'm just going to remove that x-intercepts because it's kind of in the way. I'm just going to put it over here. Okay, and this was 2. So let me copy the 2 down here. Okay, 2. And we increase 2 by h. So where do we end up? We end up here with a quantity that's 2 plus h. We'd added h to 2 essentially. Okay, so where are we going to be? We're going to be probably need to increase my parabola a little bit. We're going to be way up there actually. Okay. So on the axis, I'll stretch my axis as well. Okay. We're going to be way up here. So this would be f of 2 plus h. So what are we calculating here? F of 2 plus h minus f of 2. That's this difference here. This is f of 2 plus h minus f of 2. What is h? H is this here. So if you take a quick look, what we're calculating is by taking the ratio of these two, we're looking at the slope of this triangle. Okay? And the slope of this triangle, well, not this triangle, the slope of the hypotenuse of the triangle, should I say, is the slope of, let's stretch out the hypotenuse, it's actually the slope of the secant line. So the line that goes through the 2 points that I have here. Okay, so to sum up what I've done here, okay, we've got a parabola, we've got the value, well, this is what the function is at 2, so this is f of 2. We've got another point, which is maybe 2 plus h, a little bit further. This is f of 2 plus h. And what we're calculating is the slope of the line that passes through these 2 points. It's called the secant line. So this is what we're calculating when we're evaluating that expression. And we do that a lot in calculus. Okay, so the idea behind this is with this we can eventually calculate the slope of the tangent line. So the idea in calculus is that we take this point and then we decrease the value of h. So we actually change h so that it becomes even a little bit closer to here. And by making h as close as we want to 0, we can eventually find the slope of the tangent line. And this is what calculus is all about, the slope of the tangent line. So anyway, so we're doing, so I'm explaining this because you'll find this expression in the book and you're like, why am I doing this? You're going to do that a lot in calculus, so this is why. Okay, so f of 2 plus h minus f of 2 over h. I can use my previous work. So f of 2 plus h, I've calculated what this is. This is h squared plus 7h plus 6. And f of 2 was 6. We divide that by h. So we can see 6 minus 6 cancels out. We're left with h squared plus 7h. And let's try to see if we can, we get a rational expression. Let's see if we can simplify it. Simplify would mean that they would share a common factor, maybe that I can remove. So I can see that in the numerator, I can factor a greatest common factor of h. So I'm left with h times h plus 7, and then h and h cancels out. So I'm just left with h plus 7. And then the idea in calculus is that, okay, this is the slope of the secant line. If I make h small, or as close as I want to 0, I can see that h plus 7 is going to be really close to 7 if h is small. So in other words, by making this point as close as I can to this one, I'm going to get a slope of a secant that's very, very close to 7. So that means that eventually the slope of my tangent is 7 exactly. So this is, you've done calculus right now without me, well, with me telling you, but without the notation from calculus, but this is calculus. So don't worry if you see expressions like this, okay, and you think, oh, I'm wasting my time. You're not, okay? We're going to work with that a lot in calculus. So maybe I can write this. So this would imply, this is calculus, the slope of the tangent line at x equals 2 is 7. Okay, and we're going to look at a last example here, example 2. If you've got a function h of p, which is p squared plus 2p, we would like to solve h of p equals 3. I'm not going to start by solving it. I'm going to try to explain what we're doing geometrically. I always like to have you thinking about the geometry behind a given problem if possible. It usually helps you to figure out what's going on. So h of p equals p squared plus 2p. I'm going to think first about the graph of this function. So consider the curve y equals p squared plus 2p. Okay, so P would be there, this would be Y. Okay, now to graph this, this is going to be it's a quadratic. If I can factor it, it's going to help me sketch the graph of this function. So P plus 2, that means that I've got x-intercepts that are, well, P could be 0, right? Or P could be minus 2. So those are my two x-intercept. The y-intercept is easy. It's when you replace P by 0, you get 0 for y. So 0, 0 is, so the origin is both an x and a y-intercept. Minus 2, 0 is the other x-intercept. You've got, after that, the vertex. What's the vertex? Well, the x-coordinate is going to be halfway between the x-coordinates of your intercept, so it's going to be in minus 1. And the y value is when you replace x by minus 1. Actually, not x. Well, I wrote x, but maybe I should have written down the p-intercept here because p is my variable. So you replace p by minus 1, so you get p squared plus 2p, so that's going to give you 1 minus 2, which is minus 1. So minus 1, 1 is your vertex. Minus 1, minus 1 is your vertex. So this is a parabola that looks like this. Okay. Now when we're solving h of p equals 3, we're trying to find the values of p where the output is actually 3. So 3 is up there, right? P is, when you're looking at something like h of p, you're looking at an output. The output are on the y-axis. So position 3 on the y-axis and draw a horizontal line like this, because we're trying to find any value of p that has 3 for its y value. So the values of p we're looking for are here and here. So we're looking for, let's say this is like p1 and p2. Those are the two values of p we're looking for. Okay, we can sort of see one is a bit above 0, the other one a bit below minus 2. So let's see if we can recover those algebraically. So algebraically, how do we do that? We're going to say, okay, when we're going to replace h of p by 3 and make it equal to the expression for the output, p squared plus 2p. Okay, or in other words, I replace h of p by its expression. And then I'm going to solve this. So to solve this, remember, we try to factor, so which means I'm going to send the 3 on the other side. I'm going to factor this, so product of minus 3, sum of 2. That's the two numbers are 3 and minus 1. So immediately I get the factorization because the coefficient in front of p squared is 1. So p plus 3, p minus 1, which tells me that p plus 3 is 0. Or p minus 1 is 0, so which means p is 1 or p is minus 3. And that makes sense. P is 1 is slightly above 0, and p is minus 3 is slightly less than minus 2. So those are the two inputs which have an output of 3.